Here's a great question about simplifying final answers. We know that a simplified fraction cannot have a radical or a square root, cube root, that sort of thing in the denominator. So how do we fix these unsimplified answers so that they are fully simplified? Well, let's consider the general process here. I want to look at the example 1 over the square root of 2. We'll follow along our process as we go. So notice the type of radical that we have in the denominator, kind of the problem spot. We have a square root in this case. The numerator, no big deal. We don't really have to worry about that. It'll just kind of fall out naturally. Step 2 is what can we multiply that denominator by to get something that's not a radical? So consider that denominator, square root of 2. If I multiply it by the square root of 2, do you see how I'll end up with the square root of 2 times 2, which simplifies really nicely to 2. So I know that I can pick to multiply the denominator by the square root of 2 in order to kind of resolve the radical situation. So what I'm going to do is I'm going to take my original fraction, 1 over the square root of 2, and I'm going to multiply it. I'm going to be really strategic here. I'm going to multiply it by 1. However, my number 1 is going to be made up of that chosen square root of 2 over square root of 2. So this thing right here is the same as 1 because the numerator and the denominator are the same. So hopefully you're saying that yes, that is the value 1. So now I'm going to do that multiplication. So I'm kind of in step 4 here. Remember when I multiply fractions, I multiply through the numerator, so I get square root of 2, and I multiply through the denominator, I get 2. So in the end, I know that 1 over the square root of 2 is the same as the square root of 2 over 2. And this second fraction is simplified. The values are the same, but we call them slightly different. Let's look at a little more complex scenario. Before we do that, I want to start with a quick reminder about exponents that will be helpful for us. One reminder is that when we're dealing with a reciprocal sort of situation, like 1 over x, we can use exponents to rewrite that. We can say that's the same as x to the negative 1. Another reminder I want to offer is regards to roots or radicals. So let's say I have some type of root, the nth root, so the square root, the cube root, whatever, fourth root, fifth root. I can rewrite that using fractional exponents. So I can say that's the same as x to the 1 over n. Notice the root is in the bottom. Roots are in the bottom of trees, roots are in the bottoms of flowers, so that helps you remember. So that's my reminder. Let's jump into the same exact process, but now with a different example. So we're considering this fraction, 4 over the cube root of x squared. So notice not simplified because that denominator has a radical, and in this case we're dealing with a cube root, but we're also dealing with an x squared, so there's really a lot going on here. Let's consider that denominator. So the cube root of x squared, I'm going to rewrite this with fractional exponents. So I'm going to say that's the same as x to the 2/3. Remember my root, the third, is in the bottom, so that's where I'm getting the third. Now I want to think about x to the 2/3. I need to multiply that by something in order to get something that is not a radical, so really like x to the 1st. So think here for a second. When I multiply with the same base, remember I need to add the exponents. So I'm thinking to myself, what would work here? Well, 2/3 plus something to get 1/3. So I know it's an x in the base. I should probably add 1/3 here. So 2/3, 1/3, that will give me 3/3, so that'll work out. So let's craft our strategic version of the number 1 and multiply. And I'm going to keep fractional exponents here for a second. So here's my original, 4 over the cube root of x squared. oops, I'm sorry, I said I was going to keep fractional exponents. I did want to do that. So x to the 2/3 times, and here comes my strategic version of the number 1. So x to the 1/3 and x to the 1/3. Remember, here's the giant number 1. Okay, here I go and multiply across the top. I get 4 times x to the 1/3, or we know also that that means the cube root of x. Then in the denominator, when I multiply, I'm getting x to the 3/3, or just x. Now I'm going to simplify. So as I clean this up, there's nothing for me to simplify. I'm just going to rewrite so that I don't have fractional exponents anymore. So I'm going to say 4 times the cube root of x all over x. So in the end, I can say that that original fraction, 4 over the cube root of x squared, this one that was my answer but not simplified, can now be simplified and written as 4 times the cube root of x all over x. So this new fraction is my simplified version. So where on earth are we going to see this stuff? Well, let's check out some examples. We might use this skill when we're working with right triangles and working with the Pythagorean theorem. We might maybe see this when we're working with trig functions and side length ratios. We might see this when we're working with squares and talking about areas versus side lengths, or similarly cubes and side lengths, and seeing the volume as a function of side length. And then, as always, we might see this when we're at a party with fellow mathematicians.